Good morning, ladies and gentlemen. Welcome back once again to the CERCA Monthly Expert Talk Series, where we invite national and international experts who speak on different issues related to climate change and air pollution. Indoor air pollution is an emerging topic within India and a very important one at that, since we spend most of our time indoors. India is gearing up to frame indoor air quality guidelines, which would be the first major step towards the development of indoor air quality standards in the times to come in India. For the month of February 2023, we are pleased to present Professor Pawel Wargocki, who's the Associate Professor in the Department of Environmental and Resource Engineering at Technical University of Denmark, who would be speaking on the methodology to be adopted for setting indoor air quality guidelines in India. On behalf of CERCA, I would like to welcome Professor Pawel to the Expert Talk. Welcome to CERCA, Professor Pawel, and we are all delighted to have you with us today. Before I request Professor Harsha Kota, who's the CERCA Chair Professor, to formally introduce Professor Pawel, I would like to invite CERCA founder, Mr. Arun Dugal, to share his thoughts on the topic and say a few words. Over to you, sir.
Thank you, Hemant. Extremely delighted that we are having this talk by such a distinguished authority on the subject. CERCA was founded over 5 years ago, and we have done work in the area of ambient air quality, as well as more recently on climate change issues. But the indoor air quality, which is extremely important, we have not, in my view, had an opportunity to do sufficient discussion on. All of us recognize that indoor air quality is extremely important. Everybody spends most of their time indoors, and particularly indoor air quality in universities, in lecture halls, in other public places, cinemas, restaurants, malls, is extremely important. So I'm delighted that there is a focus now, increased focus now on this subject, and we are fortunate to have Professor Wargocki to be able to speak on this subject to all of us. Thank you very much.
Thank you, sir, for sharing your thoughts. Now I would like to call upon Professor Harsha Kota, who is also the CERCA Chair Professor, to formally introduce Professor Pawel Wargocki and invite him for the talk. Over to you, Professor Harsha.
Hi, good morning, everyone. We are fortunate to have Professor Pawel with us to share his thoughts on what India should do related to indoor air quality guidelines and how should we manage air quality in India. So we are also fortunate to have Professor Dugalji with us again today, the founder of CERCA. So Professor Pawel graduated from the Warsaw University of Technology in 1990. He received his PhD from Technical University of Denmark in 1998, where he has been teaching and performing research ever since. He has more than 25 years of experience in research on human requirements in indoor environments. He is best known for his seminal work demonstrating that poor indoor environmental quality affects office work and learning performance. Other work influences the requirements of ventilation and air cleaning. Recent research includes studies on emissions from humans, sleep quality, and performance of green buildings and gas-phase air cleaning and air quality in aircraft. He has collaborated with leading research institutions, universities, and industrial partners worldwide, including the National University of Singapore, Jiaotong University in Shanghai, Syracuse Center for Excellent United Technologies, Wilex, and Google. He stayed as a guest professor at Pufendorf Institute at Lund University, Waseda University, and the National University of Singapore. He was president and long-standing board member of International Society of Indoor Air Quality and Climate, vice president of Indoor Air 2008, and chair of ESHRE committees. He was a president of Academy of Indoor Air Sciences. He has received several awards for his work, including the Rockwell Award for Young Researchers, Ashtray Ralph Nevins Award, Environmental Health Award, Distinguished Service Award, ICIAQ's Yaglo Award, and Best Paper Awards in Indoor Air. He has published extensively in the field of indoor air quality. So with this, I request Professor Pawel to proceed with this talk with a hope that in the list of universities or institute with whom he is collaborating, IIT Delhi will be something which will be featuring in his biodata soon. Thank you. Please proceed, Professor Pawel.
Yeah, thank you very much for the very kind invitation and kind words. I would especially thank Honorable Arun Dugal and Dr. Hemant Kaushal for inviting me to give this talk, and thanks a lot to Mr. Harsha Kota for a great invitation. Welcome to all the participants for joining me for this short presentation this morning, where I would like to express my views and my thoughts about how to set up the indoor air quality guidelines in India. Well, this talk could be much, much longer, and I prepared this talk thinking more about giving you some ideas and some thoughts to reconsider when the guidelines will be developed in India. And of course, if there are any questions after my presentation or any comments, or if anyone would like me to develop further the ideas or the points that I make during this short presentation, I would be very, very happy to connect and respond. And you can always find me on my email address that is presented here. My presentation will be available after my talk as a PDF form for you, so that you can always refer if I speak too quickly between the different slides. I prepared several slides so that you can always use my presentation as the reference for any of the thoughts that you may have. My talk is more about a quest for indices defining indoor air quality. This problem is not a very new problem. It is the problem that has been with us for many, many years. And I will show you why this is the problem and which direction we should take probably in the future, introducing some of the indices that have been proposed to do that. And as Mr. Dugal mentioned in his introductory words, this is true that indoor air quality has been an important pathway for our health, our comfort, our sleep quality, our cognitive performance, work performance, our performance of children in schools, and so on. And both when we are indoors, we are both exposed to the outdoor air and indoor air. So there has to be a very concerted work to basically address both elements, both outdoor air quality that provides an important dilution and fresh air and clean air to dilute the pollutants that are generated indoors. So all that has to be considered in the future indoor air quality metric. I don't have enough time to speak about it, but one important area that will be addressed in the future, and I am addressing already now, I'm sorry, I don't have time to talk about it, is the sleep quality and indoor air quality. So if we look at the time that we spend in different environments during our lifetime, home environment and particularly bedroom are the times where we spend most of the time. And in bedrooms, we spend more than 20 years of our life. And sleep quality has significant impact on our health and next day performance. Therefore, this is an area which should be addressed, specifically addressed also when developing the indices for indoor air quality. Okay. So why there is a necessity for indoor air quality metric? In 2016, we published a paper. And the paper is about green buildings, but in this paper, we wrote like this: lack of indoor air quality metric or disagreement what should constitute indoor air quality metric is a significant barrier holding back innovation of indoor air quality conducive technologies, emergence of undocumented methods of measurements of IAQ, claiming their high efficiency and authenticity. This all resulting in undervaluing the importance of indoor air quality in different credit schemes and compliance metrics related to built environment. This is a long sentence, but it's holding all the important arguments why we need IAQ metric, even a crude one, because the main reason why we have to have an IAQ metric is that we don't have a proper reference to which we can benchmark the quality of the environments, of the new environments, of existing environments, built environments, and also to which we cannot benchmark our technologies. So without that metric, any technology can claim efficiency. Any conditions in a buildings can be claimed to meet the requirements for good indoor air quality. So there has to be some agreement on this. And of course, there have been some proposed matrices or indices for the indoor air quality. However, they have not been sufficiently good because indoor environmental quality still creates a significant problem, not only here in India, but also in Europe, in the western part of the developed part of the world. And particularly for India, this is interesting because India is developing very quickly. So India should avoid the problems that we are facing today in the developed parts of the world by not tackling the problem of developing some sort of a metric for indoor air quality in a good time. So now we have to act retrospectively on the topic, whereas India has an opportunity, it is a wonderful opportunity to act prospectively to avoid any problems in the future. So today I'll be reviewing the main indices and approaches used so far to characterize indoor air quality. There are some new rating systems that were developed recently that you may not know. I will also say a few words. And then in the end, this is what I think it's the very important part of my talk is to just discuss in which direction you should go, or one can go. This is only my personal view on that point. So we should start with the definition what the indoor air quality is. And there are several different definitions of indoor air quality, and they have a common denominator. And the common denominator is that this is the air within and around buildings. So this is indoor air quality contains the indoor air and contains outdoor air. So this is very important, that indoor air quality is related to effects on occupants of the buildings. So usually they mention health and comfort, but under the health umbrella, you can put productivity, cognitive performance of children. You can also add sleep quality, healthy life and people's well-being. It contains all the pollutants. So not only the chemical pollutants, but also biological pollutants. And we know this from the recent pandemic, and also physical contaminants. Some of them, they also suggest that the temperature and relative humidity should be considered as the element of the indoor air quality. That is to be discussed in which context it should be, but of course, it should not be neglected because the connection between the thermal environment and temperature and humidity and those pollutants that are present in those is very significant and may influence their presence and prevalence. The problem with indoor air quality metric is that unlike the other matrices that are developed, for example, for light, for noise, or for thermal environment, the universe of the indoor air is huge. We have three major groups of pollutants, which are gaseous, biological, and particulate matter. And then within each of the group or the small universe, we have hundreds of different pollutants as with regards to gaseous pollutants. With the biological agents, we have different agents that may behave differently. And then for the particulate matter, we have a range of particles and only cover 2 particles at the moment. And also we have components on the particles. So this is why it is very difficult to make the index here or the metric for indoor air quality, because it needs to cover all those aspects, and they may require different approaches, of course. But without covering of all of those, we will not be advancing. So until now, the world has used few indices, and these are why I say only those indices, because there are also other regulations regarding some pollutants on the national level. However, for those, if we look at the standards that are used in the world, the major metric for indoor air quality is the ventilation rate. Then some of the standards also use carbon dioxide, and carbon dioxide has been used recently as a metric or proposed as a metric for quality of air that does not contain infectious agents. Also in the past, the so-called total concentration of volatile organic compounds was used as the metric indoors. And then in some standards, also the occupant perception has been considered as the measure of indoor air quality. So how many people are dissatisfied with indoor air quality? You may be surprised that on this list, I don't have PMs, I don't have NO2, and so on and so on. I will come back to this, and I will say also that these are the recommended pollutants to be taken into account when we talk about air quality, but they have not been prevalently used in the standards related with the built environment as a measures of indoor air quality. So for the measures of air quality, ventilation rate has been used, CO2 has been used, for some time TVOC has been used, and it's coming back because of the use of the low-cost sensors, but many of the standards do not actually include the PM, for example, levels or NO2 levels inside the body of or the language of the standard. So about the ventilation. So ventilation is, because there is nothing else that we can measure or is difficult to measure, and there are so many pollutants, so the easiest way is to basically measure ventilation and assume that the ventilation is providing a clean air. So there are certain beliefs and misconceptions about the ventilation that I would like to discuss in this, to show that the metric may not be sufficient to guarantee that the air quality is good. So the first misconception is that more ventilation always improves indoor air quality. This is true only if the air that is delivered by ventilation does not contain pollutants, and especially does not contain pollutants that are present indoors. So if the air is polluted outdoors, there will be a dilution of pollutant indoors, but the air from outdoors will bring another types of pollutants. So there will be a change of the type of pollutants indoor, but the effect of dilution of indoor pollutants will be cancelled. Then another misconception is that the lack of ventilation or low ventilation rates means poor air quality. So ventilation, sometimes we have very low levels of pollutants indoors. All depends on the type of the emissions that are occurring indoors. So the two environments with the low ventilation may have different air quality level. One can be higher quality level because there are low levels of pollutants, and then there is another one which has high levels of pollutants, so it will be considered as the poorer quality. Then the misconception is that we can connect ventilation directly with the human response. That is a performance-based metric. So it is not a performance-based metric because it actually reduces the levels of pollutants that affect humans, and also can bring some pollutants. And also the misconception is that ventilation will remove all pollutants in spite of their type. There are some pollutants that cannot be removed effectively by ventilation, and it is simply to measure ventilation. It is not, it can be simple, but it's not that simple as we think that it is. This is just an example of how the ventilation can bring the pollutants from outside. This is the burden of disease expressed in disability adjusted life years. I don't have time to discuss about. This is a metric for the health effects. We have two columns with a red color and a blue color, and red color is when the indoor sources are dominated, and then blue color is the outdoor sources are dominated. And what we see here is the increase of ventilation rate containing outdoor pollutants, and that its effect on the health effect, or the metric for the health effects. And so you will see when we increase the ventilation, the indoor sources, the effects from indoor sources are decreasing. But at certain time, when all them are decreased, this is only just a model example, then suddenly the pollutants that are brought by outdoor air become to dominate, and they create some health risk. So again, with what I said from the beginning, indoor and outdoor air has to be considered in a metric for indoor air quality, because we cannot deal only with the pollutants that are generated indoors. This is just an example for how it means that the different levels of ventilation can create at different levels of dissatisfaction or air quality. Here on the Y scale, you have a percentage of dissatisfied, so dissatisfaction with the air quality, and on the x-axis we have outdoor air supply rate. So let's assume we have a 10 liters per second per person. It's about 36 cubic meter per hour per person, or 20 CFM per person. And then we have a building which has different types of pollution sources indoor. So there is ultra low pollution sources, so there is very little emission, and low emission, and then non-low emission, so different lines. So you can see at the same ventilation rate, you may have a different dissatisfaction with the air quality. So different level of air quality. And the reason for that is basically that sources and the source strength, a load of pollutants indoors, will also determine how much ventilation should be brought, and showing that maybe ventilation is not that good a metric for indoor air quality. And this is an example of how ventilation is not directly related to human response. So this is basically not a performance-based metric. And exposure. Because of the exposure, human uptake of exposure, we have health and comfort effects. So exposure should be regulated, and pollutants that cause exposure should be regulated. Ventilation plays a role to dilute those exposure or increase the exposure. It brings pollutants from outdoors. And then there are also various indoor sources of pollutants that actually can elevate the exposure. So summarizing, although simple, relatively easy to verify, and readily available ventilation rate as is used today may not be considered as a solid and credible metric for predicting indoor air quality. It can be used, but it should be used together with other types of metrics, because in itself, it cannot provide a sufficient reduction of risk related to indoor air quality. And that is also seen through the history, where ventilation rate has been, this is the ventilation rate, the line, and how it's changed through the history. You can see we started from very low, 2 liters per second per person, and today the ASHRAE is talking about 10 liters per second per person. Some scientists suggest that the ventilation rate should be about 25 liters per second per person. Look at this peak. This is a Billings, and Billings proposed in 19th century the ventilation rate for dealing with infection diseases. It was tuberculosis. Those ventilation rates were very, very high. And these are the ventilation rates that you see in the hospital environments today, but to reduce the risk for infections, but we do not see those ventilation rates in buildings. Then CO2. I will not go through this historical view of CO2. So CO2 has been with us indoors for years. So CO2 is not only the issue for which is outdoors, but also indoors. And it has been proposed to be a metric for indoor air quality already by Lavoisier in the 18th century. Well, in the 19th century, Pettenkofer, who proposed the CO2 as the marker of ventilation, he said that it is a surrogate for ventilated air, but not causing any problems with the for the humans. And even the studies later on shown that even exposures to 3–4% of CO2 indoors normally will have 0.5 maximum percent. But even those high and outdoors 0.05%, that would not cause negative effects. So CO2 has been proposed as a metric and has been also discussed in other contexts. But this CO2 has several disadvantages. And one of the disadvantages is that there are time effects. It is highly variable, and we assume often steady state. So CO2 is emitted by humans. So we generate CO2 because of the metabolic processes. Depending on how many people are there, depending on our activity, on how long we have been exposed, we've been in a building, in a space, their CO2 level may vary all the time. So there is a temporal variation, and even there is the spatial variation of the CO2. And we need to know how much CO2 is emitted. So we don't know that because we have different activities. And so CO2 is good marker of ventilation, nothing more. And it contains all the same pros and cons of ventilation as a metric of indoor air quality. There is a document recently published about the CO2 by ASHRAE. It's called ASHRAE Position Document on Indoor Carbon Dioxide. And I will not go through this document. I just want to flag it so that you can go upload it afterwards and read. There is a lot of information that is useful if one wants to consider the CO2 as a metric for indoor air quality. Another metric that has been used in the past is a TVOC. So as it comes to organic pollutants, there have been attempts to define some sort of a measure that will capture the effects of many organic pollutants that are present indoors and how they combine. And that metric is called TVOC, or total volatile organic compounds. According to original definition, this is the sum of polluting molecules between C6 and C16. Today, when we purchase the low-cost sensors or some sensors that measure TVOC, we don't know what they measure, first of all, and some of them, they claim to measure TVOC, but actually they measure equivalent concentration of the response of either acetone or butanol or any other reference, or toluene or any other reference gases. So actually, to define TVOC, you would have to make a gas chromatographic measurement and add all the molecules between C6 and C16. And please note, PVOCs, very volatile organic compounds, and SVOCs, semi-volatile organic compounds that we know are very important for our health, are not considered by the metric. And there have been some dose-response relationships that were developed for those types of for the TVOC, for this metric. And basically they say that the levels below 200, 300 micrograms per cubic meter would not create any risk for irritation, discomfort, health. However, the literature that has been reviewed afterwards, trying to find an epidemiological or laboratory relationship between the levels of TVOC and effects on humans, was very inconsistent. So that literature suggested to drop the idea of using TVOC and use some of the other metrics, perhaps, to define organic pollutants. I would like to come back to TVOC for a little while, because one of the relationships that was, or recommendations that were made, was made not only on the sum of all the pollutants, but also the sum of for the different groups such as alkanes, aromatics, terpenes, esters, halocarbons, and so on. I think this direction is very, very interesting because it is not dealing with all the pollutants identically, and those pollutants may have a different effects where they, although different groups of pollutants. So this is maybe the direction, but generally TVOC has not been recommended as a consistent metric for this. And finally, for the assessment of humans, that has been used in the past, and the late Professor Fanger, with whom I had a pleasure to collaborate for years, proposed the idea that since we are not able to detect all pollutants using chemical instruments, and the chemical instruments are very difficult to use and expensive, we can use the human response. So when people assess the air quality, whether this is acceptable or not acceptable, that can be used as a metric of air quality. And actually, this metric is in the title of the ASHRAE standard for ventilation. This is the ventilation for acceptable indoor air quality, and they define the benchmark as the 80% satisfaction with the air quality. So 80% of the group should be satisfied with the air quality. So that has been used in the past. It contains also several advantages, but also several disadvantages, as normally in everything in the life. So it is not surprising, but has been less and less in use, and also very difficult to implement in the practical applications. But that is probably a major limitation of that approach, because there are different factors that disturb this measurement. So it's a type of measuring scale, transformation, temperature, humidity, length of exposure, and so on. So it is difficult to apply that metric in the future. So there are major drawbacks of previous attempts is that address mainly exposures to chemical compounds, address one modality usually. So they use usually this comfort. And if you think about ventilation requirements in the world, these are basically main on the comfort, not health. They have arguable reliability and repeatability, and mostly they're related to ventilation compliance. So basically, if you use the CO2 as a metric, you check whether ventilation is sufficient. The same applies for the TVOC, if at all used, and the same for the sensory perception. There have been other multiple pollutant metrics that have been proposed. I have actually published a paper that is not listed here, but I can share in the afterwards, where those metrics are summarized, and they are based on different approaches. One approach, that is the first one here, is that it's a VOC metric that is based on the VOCs that cause effects on humans, and then adding them up and considering them. Then there is the indoor air pollution standard that is based on the different types of pollutants, and attributing the weighting factor, the importance of them for the effects on humans, the tolerance index that is based on the exposure limits, and also some that are based on the pollutant grouping. So looking only at the human occupancy, occupant activities. That have been used in different applications and as a different proposal. I show them because I don't want to give an impression that have not been any attempts. There have been attempts, and some of them are more successful, less successful. But in the end, we don't have agreeable metric. I would say example of an agreeable metric is DALI. For example, WHO introduced disability adjusted life years, and all the health effects, all the effects that are actually presented by WHO are expressed by DALIs. So we miss that, so that makes it difficult for us to make comparison and effective solutions and for dealing with the air quality problems. So there has been a project in which we actually looked at other methods for developing indicators for assessment of indoor air quality. I just present those as the reference to the material that I've shown. I will not speak to it. And in one of our projects, we looked at the low energy buildings and the non-low energy buildings, in which we try to look at the types of pollutants that are measured in those buildings, trying to estimate some sort of a metric that would represent the pollutants that are present indoors. And this is the list of pollutants that we found that they are measured in the buildings which are called low energy residential buildings, most of them. And then by having this list of those pollutants, we looked at their long-term exposure effects, looking at their index for acceptable level of those pollutants and the short-term effects. So some sort of the occupational limits and then cell limits, short-term exposure limits. And in this way, we try to develop a metric that consider the effects of indoor air quality on the long-term exposure and short-term exposure for those different types of pollutants that have been identified, and comparing the effects of those pollutants, comparing them with the exposure limits, and also expressing those effects with disability adjusted life years. So this is one of the other example of the metric that can be used. Recently, together with my colleagues, we introduced so-called tail rating scheme. This tail rating scheme is a very, very new thing and has not been known to the general population because it's actually developed during the pandemic. And tail rating scheme considers the indoor environmental quality that is expressed by the Roman number in the middle, and it contains 4 different components of indoor environmental quality: thermal, acoustic, A; indoor air quality, I; and light or luminous environment, L. I will not speak about the others, only about indoor air quality. The most important, it has 4 levels of or categories of quality that are expressed by colors and by the Roman numbers. The highest is 1, the lower 4, the worst is red, the highest is green, and it actually combines those all levels of categories of quality of those different components to express the overall quality of environment. Because the combined effects are very important. We should not only consider air quality, but also how indoor air quality interacts with other parameters like a thermal environment, acoustic environment, and luminous environment, and how all of them together interact and affect occupants of the buildings. So in this tail, we'll selected 12 indoor environmental quality parameters and the following indoor air quality parameters. So if we talk about indoor air quality metric, for that particular metric, we use the metrics that are used because our idea was to create a very crude metric and very simple metric that can be applied in the practice, but at the same time, it is the metric that is of a good quality. So it's not that it should be crude, but it's of good quality. So we selected CO2 and ventilation rate because that has been prevalently used, and industry and designers are used to have this. Then we selected formaldehyde, benzene, PM 2.5 because they are on the WHO list of pollutants. And then we selected radon because radon we know that has health effects, and also indoor relative humidity in connection with the possibility or potential for the mold growth and fungi. So we also have also visible mold. So as you can see in that metric, we cover gaseous pollutants, we cover particulate matter, and we also cover the biological pollutants. We don't have infectious agents. This maybe in the future we develop a separate metric that will only consider this, or maybe integrated with this metric. An important thing about the tail, I'll come back to this again, is that this is a performance-based metric, meaning that it is based on the actual measurements in the building and the actual operation. Many of the metrics are based on the so-called asset rating. I'll show you one in a moment, but the tail is actually based on the measurement. We developed a sister or the brother to tail, which we call the predict tail, that can be modeled. So basically you can model the levels of those parameters, predict how they are in the building, but the actual rating of a building should be based on the measurements, not on the what the building can deliver. That has been suggested by so-called IEQ compass. So then parallel to the, during pandemic, parallel to the tail, there have been other attempts to develop some of the labels for indoor environmental quality, and that this system is only for residential environment, and it's called IEQ compass, indoor environmental quality compass. As you can see, it's very comparable to the energy classes, so or any other metrics that I use in also certification schemes. So I have different classes, A, B, C, D, E, F, G. G is the worst, and A is the best, and then it all depends on the score. However, this metric is an asset metric, which means, and it's an asset rating, which means that certain characteristics and features of a building are assessed in consideration of different aspects of the quality of the indoor environment. Here I give an example of 4 parameters that are defined for describing indoor air quality. And this is impact of outdoor air, building ventilation and materials, impact of household activities, and occupants as possibilities to adjust indoor air quality. Each of these parameters have weightings, and the weightings are based on the expert group decision. So it is not a weighting that is based on actual measurements or actual, these have been predefined during the developing of those parameters. And then there are different criteria for different parameters. So you can see here, and they have also different weights. Again, that the weighting is determined by the expert group. The most important here is to say is that those criterions define what the building can deliver. So this is an asset rating. So we construct the building and deliver the building that should deliver let's say, for example, B class indoor air quality in a building, right? However, the building can be operated differently, and in actual operation, it can actually deliver E level, but not B. Even though it can, on the paper, deliver B, it delivers E. And this is the advantage of the tail rating, which is actually a performance based on actual measurements. Okay, and then one attempt to define the metric is QALY and DALY. I mentioned a little bit about DALY, disability adjusted life years. This is a retrospective measure of the effects of the pollutants on human health. And QALY, this is a prospective measure. It's more or less the same stuff, but DALY is used by WHO. So this opportunity to use DALY, which define lost years in work because of the premature death or being not able to work. So there have been attempts to define the pollutants of concern based on the DALY metric. This is an example of the study of the measurements in the United States, where they measured in several thousand dwellings the levels of concentration of pollutants, and you can see it on the lower part of the figure. And then what they did is they defined the effects of those pollutants on health in terms of DALY. And actually, in terms of DALY, you can see here's a lot of variation and distribution. And in terms of DALY effects, only few pollutants have been considered to be important. So this is one of the ways how the pollutants for the metric can be defined. And for those who are interested in this, there have been a project, and this is the website that try to compare different guidelines for air quality around the world, and then they provide for different countries how the air quality is for the inspiration. But of course, I believe that our excellent references, WHO air quality guidelines, they define the pollutants for indoor and ambient pollutants and their levels. And actually, these are based on the health effects, and they create a wonderful source of reference of pollutants that have to be dealt when we discuss indoor air quality guidelines. So both the ambient pollution levels and indoor pollution levels should be considered in that metric. And of course, there is a new guideline which creates a very severe, I would say, or demanding levels for air quality. But I think this is a very good way of doing this. So we have the challenges. We have an incomplete data on exposures to low levels of pollutants. We lack understanding of interactions of those pollutants. We lack the reference values for many pollutants. Measurements are challenging. There is a time variance of exposures. There is a huge variation in human susceptibility and sensitivity. And so you can say, well, it's too many limiting factors and too many challenges that such a metric would not be possible. However, I believe that this is possible because I say that even we must act on the incomplete information. And the late Professor Fanger that I mentioned, he actually once said that brother Wrights did not know all the rules or the laws of aerodynamics and they could fly the plane. I think it is the situation today for us. Instead of discussing all the time new chemicals that will be coming to indoor environments all the time, it makes sense to work on the information that we have and create some benchmarks to start to improve at least on the knowledge that we have today. So how we can advance? I have about 3 minutes more, if you allow me to finish my presentation, because this is basically the view of how we can do it. So I think there are 4 questions that needs to be answered when one has to develop the IAQ metric. It is, what is the premise and the purpose of the metric? What are the basic conditions that must be fulfilled? What should constitute the principal elements of the index? And should all pollutants and all modalities be addressed? Basically, what it means is, should we use it for children or adults, for mixed population? Should we use it in special types of buildings? Should we use all types of endpoints? Or maybe only one endpoint we should consider, and so on, so on. So all those aspects needs to be addressed. So to me, the premise is that basic human requirements should be met. Indoor air should not compromise the basic human requirements, which include high quality of life, good health, optimal physical and mental activity. So I think that should be the denominator, the most important objective. It should consider full spectrum of pollutants. Today, we see indices that only look at the gaseous pollutants or maybe PMs. Now there's a lot of debate about the infection agents. But if we talk about infection agents, we have to consider the effects on gaseous pollutants as well. And they should use single or multiple criteria or indices. What is the purpose? So I think the basic purpose should be health of humans. And then the question would be then, should there be voluntary or mandatory? So that part of the metric can be mandatory, part can be voluntary of that, or only can be mandatory. So also the metric can be different if it's used for the design and when it's used for the operation. So there could be some differences between this. And conditions. So now this is the question about resilience of buildings. Should we today design the buildings, for example, our indoor air quality metric for the future potential pandemic that may occur? An example of that would be we install the fire protection systems in our buildings, and they may never be used, but they are installed, even costly. So the question is whether this metric should also be considered. So for the approach, what are the basic requirements, adaptation from already existing indices, and whether we should use a precautionary principle, which means act on insufficient evidence. So that is the roadmap that I think can be implemented when developing the metric. Is why, so define the purpose of the metric. Step 2 is what, define the performance compliance criteria, and 3, how define the markers on indices of pollutants of concern. I will not go through this long list because the time is coming to the end. So what are the potential tentative actions for authorities? It is, in the absence of, I think, other credible metric, I think CO2 should be used, but it should be described about its limitation and should not be used as only as an average levels. The CO2, this is my idea for the quick implementation or quick development of a metric. And then I think the CO2 should be supplemented with few other parameters for defining outdoor air quality. It's a PM2.5 and NO2. And then as a minimum, we should require the submission to WHO air quality guidelines. For example, define also the levels of ozone. So there is information available, and it's only the decision that has to be taken to do it. So then ventilation can be also still considered, but it should implement regular inspection of ventilation and recommissioning, and also the education of the personnel that is using it. Finally, I think the decision that has to be taken is to regulate building emission, at least in the limited range, because we cannot, by the building technological solutions, only solve the problems of indoor air quality. We need to regulate emissions, and emissions outdoors and indoors. There have been some examples of regulating indoor emissions, and that have been done in Europe, where the so-called list of LCI, of the pollutants of the lowest concentration of interest, have been developed, around 200 pollutants, and this is the reference for that list that can be used. Unfortunately, it has not been implemented because of the complexity of the problem, because it's about 200 pollutants on the list. So with this word, I would like to once again thank you for participation in my talk. Thank you very much for listening to this. I am happy to address any questions and comments at this time. And if we don't have time to do it, please contact me at the email address that is provided at the bottom of this slide for any additional comments and questions. And thanks again. And please, the screen is open for discussions and comments. Thank you.
Thank you, Professor Pawel, for this insightful presentation and sharing your experience with us, research experience. So now moving to a Q&A session, we have a couple of questions from the participants in the chat box. So the first question is from Mr. Sunil Kumar. The question says, indoor air quality studies are not following the standard protocol. There are significant differences in the terms of monitoring, period selection, parameters, and reporting of data. What is your take on this?
Well, I completely agree, and that's actually because this is the problem is that we don't have the standard list of the pollutants that we should measure, and then the next step is we don't have a standard methodology. I always give an example of the development of the smartphone technology, where they actually collect all the time the information about the performance using the same principles and the same parameters, so they can further develop. In our profession, we don't have that standard methodology. So if you go to any journal that publishes papers related with indoor air quality, and you select 10, 15 papers, all the papers will provide the levels of, for example, carbon dioxide, but each of them will be measured differently. And then you will never know which one is actually the right one. So developing the metric or an indoor air quality index requires also developing a manual or standard protocol for the measurement to be able to compare across different measurements, across different environments. This is the condition that must be fulfilled. So I fully agree with that. We don't have that one, and I am in the process of setting up the group to at least develop the standard measuring protocol for carbon dioxide. Thank you for your question.
Okay, so next question is from Swagatha Day. The question says, in the absence of standards for low-cost sensors in India, how do we measure the indoor pollutants?
I think we know which pollutants should be measured, and they are on the WHO list. So, and for many of those, there are methodologies that can be used and applied, and there are sensors. For PM, there are sensors. For NO2, there are sensors. For formaldehyde, there are sensors. So at least those pollutants that we know that have health effects can be measured. CO2 can be measured. I am a little bit worried that we use a TVOC because we don't know what it is. I just want to tell you that we are in the process of developing the sensor that would be allowing measurements of tail and also those pollutants that are on the air quality part of the tail. So we try to make some attempts to be able to standardize this. To the first question also, I would like to say that we should probably develop a minimum protocol and a minimum list of pollutants that every one of us should measure. That would be our benchmark. And of course, any of the other measurements can include additional, but there should be a minimum core types of pollutants that should be always measured.
So next question is from Yash. The question is how to conduct indoor air quality study for a university campus. Please suggest things to take care while conducting the measurements and analyzing the data.
There are two approaches for this. First of all, the one approach would be a cross-sectional study where you would be comparing across the different buildings and measure the actual conditions in a buildings and what they appear in those buildings. For that type of measurements, I would recommend at least week to months monitoring, if possible, but at least a weekly monitoring, selecting of representative spaces for this. I have in the tail protocol, we have actually identified the ways how to be done, and also considering at least two different severe, very much different seasons. There's another approach that you can do is that you can select, if you are interested only in the referencing or benchmarking this, so you can use this approach. The other approach you can do is basically to create some sort of an intervention study. So in the part of the university buildings, you can actually introduce certain interventions that will modify air quality, and then you will compare this against the actual conditions. And in this way, you will be able to see for the same type, but the same group of buildings and the same group of people, whether those measures that you take are effective. I would be very happy to discuss offline with a person who asked this question, I'm so sorry, or if you are attending the conference in the next 2 days, I will be also happy to talk briefly about this and also provide you with some good reference for the papers. Thank you.
So next question is from Mr. Suresh Yadav. The question says, how can we generalize the indoor air quality indices in Indian cities contest, and how to overcome the variation in the houses in slum, industrial, commercial, rural, low-income group, medium or high-income group area inhabitants?
Well, this is excellent question and very difficult to answer, but I would suggest the multi-layer approach and actually avoiding generalizations. So there will be a list of pollutants that are common for any type of environment. And those pollutants should be always considered. And then you can apply regional approach. So which means that maybe some regions have different types of problems than the other regions. And they do not have to address some types of pollutants that are not relevant for this region. A very good example is radon. Not all the buildings would have the risk for radon. You need to be in a radon-prone area, right? So the same approach can be here used in India. And then for the indoor, often the indoor air quality scientists and research is blamed for not dealing with indoor air quality problem. But the responsibility cannot be put only on the indoor air science, because indoor air quality is a composite of different elements. And one of the elements is ambient air quality, for which indoor air quality scientists have very little impact. And also the other component is the emissions from building materials, for which we, again, have no any impact. So there has to be a concerted action to deal with those aspects. And then finally, for those who are living in rural areas or very, very poor, here we actually, there has to be a different approach, and we need to consider the way how at least the minimum requirements will be established, and to help those people to at least minimize their exposure. That is a very complicated problem that I think I cannot address very quickly during this talk.
Thank you, Professor Pawel. So,
hello, Priyanka. We are muted. You're muted. We cannot hear you.
Sorry. So I just want to all the participants to that in the interest of time, we could not able to take all these questions here. So we will pose these questions to Professor Pawel directly on the email. And so now moving forward to our formal vote of thanks part. So on behalf of CERCA, I want to extend my sincere thanks to Professor Pawel for accepting our invitation to deliver this talk. And it was real pleasure and honor to host you as an expert speaker this month. I also want to sincerely thank Mr. Arun Dugal, our founder, who has accepted to be part of this talk and share his valuable thoughts with all of us. And finally, I also want to personally thank all the participants representing from different sectors who took time off from attending this talk and making this session interactive through Q&A session. Thank you once again. And we will announce our next scheduled talk via social media and email very soon. Thank you so much.
Thank you once again for the invitation. And as you said, this is also I wanted to propose. Please send me the list of all the questions and I will try to answer them tonight or tomorrow, and then you can post it to all the participants. Thank you very much.
Thank you, Professor Pawel. And
thank you. And for those who are, and I hope to see some of you at the conference tomorrow.
Sure,
Thanks a lot.
Tomorrow, yeah.
Thank you. And have a good day. Thank you for joining. Bye-bye.
Bye-bye.